Hello, and welcome to Math Matters. I'm Mrs. Halpin, and today we're going to be learning how to find the area of a triangle by exploring relationships in real-world scenarios. For this lesson, you will need paper and a pencil or something else to write with. We will pause while you take a moment to gather those materials. This is a picture of my grandmother's quilt. What mathematical relationships do you see? You might be thinking about patterns that you see or fractions that you notice. There are so many relationships within this image. In our last lesson of Math Matters, we discussed the relationship between area and perimeter of triangles and rectangles. We noticed that the area of a triangle is half the area of a rectangle. Do you see the relationship within this picture? Let's look at this square bolded in black. The square was cut in half diagonally. I can see that the green triangle covers half the area of the square. During our last episode of Math Matters, we discussed area as the amount of space that is covered in a two-dimensional shape. We can find the area of this triangle by counting the square units inside of the shape. I can count 8 square units within this shape. Remember that two of the right triangles put together would give me 1 square unit. That's why I counted 7 twice, because two of the right triangles would give me 1 square unit. So now that I've counted the square units within the triangle, I can see that the area of the triangle is 8 square units, or 8 units squared. Now let's explore the relationship the area of the triangle has to the area of the square. The square has a length of 4 units and a width of 4 units. I can use the formula area equals length times width. I could also say the square has a side length of S, so I could use the formula area equals side squared to find the area is 16 units squared. What do you notice about the area of the triangle and the area of the square? The area of the triangle is half of the area of the square. Take a moment to think about which image doesn't belong. Jot down your ideas. If you think of a reason that one image doesn't belong, try to think of a different reason another image might not belong. There are so many ways you could think about this question. There's not just one right or wrong answer. You might be thinking, I don't think D belongs because half was created by drawing a line down the middle to create two rectangles. I don't see the halves as triangles. You might have thought B doesn't belong because it's the only shape with one diagonal. Or you might have thought shape A doesn't belong because the triangle is in the middle of the rectangle. You may be wondering if the blue triangle is half of the entire rectangle. Let's take a closer look at shape A. You might be thinking, this triangle looks a little different. This triangle is in the middle of a rectangle. Do you think the area of the blue triangle is half the area of the entire rectangle? I notice that if I split this rectangle in half, I will have 4 centimeters for each side length. I can move or reflect the yellow triangle on the left side onto the blue triangle. The yellow triangle completely covers half of the blue triangle. The dimensions have not changed. Each side length is still 4 centimeters. Now I can take the yellow triangle on the right side and reflect it or move it into the remaining blue section. The yellow triangles completely covers the blue triangle. The area of the blue triangle is the same as the area of the 2 yellow triangles. This means that the area of the blue triangle is half of the entire rectangle. I can also prove that the area of the blue triangle is half the area of the entire rectangle by counting the square centimeters. First, let's look at the area of the rectangle. I know the length of the rectangle is 8 centimeters, and the width of the rectangle is 4 centimeters, so I can find area using area equals length times width. The area of the entire rectangle is 32 centimeters squared. We don't know the formula for finding the area of the triangle yet, but we can count the square centimeters. I have 12 square centimeters. Now I will combine the half square centimeters to make whole square centimeters. I can see the 2 right triangles at the top make 13 square centimeters, and then 14 square centimeters, 15 square centimeters, and then I can combine 2 more to get 16 square centimeters. The area of the triangle is 16 square centimeters or 16 centimeters squared. What is the relationship between the area of the triangle and the area of the rectangle? Again, we can see the triangle has an area of 16 centimeters squared, which is half of the rectangle, which is 32 centimeters squared. We can use the relationship between the area of a triangle and the area of a rectangle to understand the formula for finding the area of a triangle. The formula for finding the area of a triangle is area equals 1/2 base times height. Let's determine how to find the base and height of a triangle. We know that to find the area of a rectangle, mathematicians can multiply the dimensions of length times width. When we're finding the area of a triangle, we use different terms. Instead of length and width, we use the terms base and height. 8 centimeters is the length of this rectangle. It is also the base of this triangle. In this case, the base and length are the same because the base is perpendicular to the height. The base is the bottom of the triangle. 4 centimeters is the width of the entire rectangle. When we're looking at the triangle, 4 centimeters is also the height of the triangle. We do not call it width because it is not a side of the triangle. The height of the triangle is perpendicular to the base. It is the distance from the base to the highest point of the triangle. Remember, there is a relationship between the area of the triangle and the area of the rectangle. The area of this triangle is half of the rectangle, which is why we find only 1/2 of the base times height. So 1/2 of the base of 8 centimeters times the height of 4 centimeters is the same as 1/2 of 32, which is 16. The area of the triangle is 16 centimeters squared. Now let's use this formula to solve a real-world scenario. Let's revisit my grandmother's quilt. I want to find the area of that gray triangle on her quilt because she wants to make more patches of this quilt, so I'm going to need some more yarn for her. I want to find the area of that gray triangle on her quilt. I can see that the base is the bottom of the triangle. It is perpendicular to the height of the triangle. The base is 5 centimeters. The height of the triangle is 4 centimeters. I can see this line is the distance from the base to the highest point on the triangle. I can use the formula area equals 1/2 base times height to find the area of this right triangle. When I take half of the base 5 times the height 4, I can see that the area of the triangle on my grandmother's quilt is 1/2 of 20 or 10 centimeters squared. Jason found the area of the triangle. He used the formula area equals 1/2 base times height and found that the area is 30 inches squared. Do you agree with Jason's thinking? Why or why not? Can you find a mistake in Jason's work? What feedback would you give him as a mathematician? Jason used 5 inches as the height of the triangle. We can call 5 inches a side of the triangle, but it is not the height of the triangle. 4 inches is the height of the triangle because it is perpendicular to the base. The base of the triangle is 12 inches. So when we look back at that height of 4 inches, it is the distance from the base to the highest point on the triangle. So when looking at Jason's work, we need to replace the height of 5 with the real height, which is 4. Now I can find half of the base 12 times the height 4. 12 times 4 equals 48, and half of 48 is 24. The area of the triangle is 24 inches squared. Mistakes help our brain grow, and discussing mistakes helps us to become stronger mathematicians and stronger communicators. So we're really grateful not only to Jason for making a mistake, but also anytime you make a mistake, it's a great learning opportunity. In today's episode of Math Matters, we learned how to find the area of a triangle. We explored the relationship between the area of a triangle and the area of a rectangle. We found that the area of a triangle is 1/2 of the area of a rectangle. We use this relationship to understand the formula for finding the area of a triangle. I'm Mrs. Halpin. I hope you have a great day and keep on counting.